This is the Explanatory Model Analysis podcast about various techniques for explainable artificial intelligence. I describe methods for visualization, exploration, and explanation of machine learning models. This episode is about the breakdown method. In this episode, I will show you how to use the breakdown method implemented in the lately published DALEX package for the Python language. If you are interested in examples for R or other XAI methods, you can find other episodes at tiny.cc/DALEX webpage. Before we jump into the Python code, let me remind you what breakdown is for. Breakdown is the model agnostic method. It means that it works for any model without assuming anything of its internal structure. It can be used for neural networks, random forest, tree boosting, or linear models. It is also an instance-specific method. It means that it explains the result of the model for a single observation. For the example related to the sinking of the Titanic, the breakdown method explains model results at the level of predictions for individual passengers. The purpose of this method is to break down the model result in components that can be attributed to individual variables. In this slide, we have an example for a single passenger, the 8-year-old boy from the first class. The model prediction for him is 0.466, and it is higher than the average result of the model, which is 0.322. The breakdown method analyzed the model and assigned to a young age, for instance age equal 8, a positive effect of 0.204, to the first class a positive effect of 0.101, and the sex a negative effect of -0.056. Effects of other variables are listed below. The effects of all variables sum up to the prediction for this person, so the sum is equal to 0.466. Such decomposition is very useful. We can read which variables have the largest contributions to the final prediction of the model, but we also have an assessment of how big these contributions are. Let's see how to do such breakdown in Python. This episode is focused on the software. If you want to learn more about this method, you will find its description on pbycheck.github.io/EMA. In this example I will use the Titanic data. Probably you have heard about it before. It has only a few variables like age, gender, class, and so on. Some continuous, some categorical. Each one is easy to understand. We will drop rows with missing values to simplify the model and encode target variable to zeros and ones, where 1 is survived. Due to categorical variables in the dataset, we need to include some pre-processing in our model. We split pre-processing into two parts. First, one hot encode categorical variables. Second, scale numerical ones. Then we combine this in pipeline with actual model. Gradient boosting machine. All used in construction algorithms are taken from the scikit-learn package. The model is trained to predict the chances of survival based on 8 variables. Different models have different structures, so if we want to be model agnostic, we need to create a wrapper around the model that has a uniform interface for the model. Here we construct the explainer object from DALEX package. The first argument is the model, then optionally we can specify the data and target variable and the label for the model. The label will appear on plots. The breakdown method works on the instance level, so we need an observation for which we can generate the explanation. Here we create a pandas data frame with a single row that corresponds to an 8-year-old boy from first class. Note that this has to be a pandas data frame, not series or NumPy array. The model prediction for this boy is 0.81. Once we have the model and the instance of interest, we are ready for the breakdown method. Here we use the predict parts method of the explainer object. In the basic settings, this method expects two arguments: the new observation and the type of attribution. By default, the type is equal to I break down. That will be covered in the future episodes. However, we will put type as breakdown. The result is a newly constructed object of the breakdown class with field called result, which is a data frame with attributions for each variable in the model. In most cases, a plot is easier to read than a table with numbers. The result can be further processed with the plot method. The general workflow with the breakdown method is summarized in this sequence diagram. Once you have a model, you need to create a wrapper around the model with the explain function from the DALEX package. All other functions from this package operate on such objects. To calculate breakdown attributions, you can use the predict parts function with the type equals breakdown. The result can be further processed with the generic plot function. Find more examples and more details in the Exploratory Model Analysis ebook. The list of all episodes is available on the website tiny.cc/DALEX. If you have any question or comment related to this topic, please let me know.